Hi everyone, in this video we're gonna explain about the classification of fluid flows. The first is viscous versus inviscid regions of flow. The flow in the which frictional effects are significant are called viscous flows. Boundary layers flows are the example of viscous flow. However, in many flows of practical interest, there are regions, typically regions not close to solid surfaces, where viscous forces are small compared to inertial or pressure forces. The development of viscous and inviscid regions of flow as a result, inserting a flat plate parallel into a fluid stream of uniform velocity is shown. The fluid sticks to the plate on the both sides because of the no-slip condition, and the thin boundary layer in which the viscous effects are significant near the plate surface is the viscous flow region. The region on the both sides away from the plate unaffected by the presence of plate is the inviscid flow region. The next point will be the internal versus external flow. A fluid flow is classified as being internal or external, depending on whether the fluid flows is confined space or over a surface. What is internal and external flow? Internal flow is a flow in a pipe or duct if fluid is completely bounded by the solid surface. For example, water flow through a pipe or duct. Internal flows are dominated by the influence of viscosity throughout the flow field. But in comparison, external flow is a flow of unbounded fluid over a surface such as a plate or a wire is external flow. For example, airflow over a ball. For external flows, viscous effects are limited to the boundary layers and wake turbulences.
Now I'm going to explain about the steady flow. The definition of the steady flow refers to the condition where the fluid properties at a point in the system do not change over the time. For an example, like a steady flow, a fluid is flowing through a pipe of variable diameter under a pressure 8. The second one is the unsteady flow. Unsteady flow is a flow which the properties of the fluid varies with time. The example for the unsteady flow is a fluid is flowing through a pipe of variable diameter under a variable pressure due to an increasing or decreasing water level of the reservoir, or opening or closure of a valve, or stopping or starting hydraulic machines connected to the pipe. A forced flow is defined by a fluid is forced to flow over a surface or in a pipe by external means such as the pump or a fan.
Next, I'll be presenting the laminar versus turbulent flow. Laminar flow is can be said that characterized by fluid particles following smooth paths in layers with little or no mixing. It also can be said as highly ordered fluid motion characterized by smooth layers of fluid. The flow of high viscosity fluids such as oil at low velocities is typically laminar. It also can be said that the velocity, pressure, and other flow properties at each point in the fluid remain constant. Slow pipe water is one of the best examples of laminar flows. Meanwhile, turbulent flows characterized by chaotic changes in pressure and flow velocity. It also can be said as the highly ordered fluid motion that typically occurs at high velocity and is characterized by velocity fluctuations. The flow of low viscosity fluids such as air at high velocity is typically turbulent. Surf, fast flowing rivers, and smoke from the chimneys are the examples of turbulent flows. Meanwhile, a flow that alternates between Being laminar and turbulent is also can be said as transitional flow. Next, I will be talking about compressible versus incompressible flow. Compressible flow is having a significant changes in fluid density while all flows are compressible. As an example, when analyzing rockets, spacecraft and other systems that involve in high-speed gas flow or flow speed is often expressed by Mach number. Mach number is an equation used to find the compressible flow, which is MA equal to V over C, where V is representing speed of the flow and C is representing speed of the sound. High-speed aircraft, jet engines and air and rocket motors are examples of the compressible flow. Meanwhile, incompressible flow is a flow in which the material density is constant within a fluid parcel and infinitesimal volume that moves with the flow velocity. Or it can be said if the density of the flowing fluid remains nearly constant throughout. Next, I will be talking about 1, 2 and 3-dimensional flow. One-dimensional flow is the flow in which the velocity is the function of time and one spaced coordinate x is called as one-dimensional flow. In example, following through a pipe is considered as one-dimensional flow. Secondly, two-dimensional flow is flow in which the velocity is the function of the time and two space coordinates which are x and y. The examples are flow at the mid part of an airplane wings, viscous flow between parallel plates, and flowing along spillway. Thirdly, three-dimensional flow is converging and diverging pipes or open channels are three-dimensional flow. River flow and inlet of nozzles are the example of three-dimensional flow.